Welcome everyone. My name is Krishna Mamidipaka. I'm a principal program manager on the Azure Stream Analytics team, and today I'm going to be joined by Henning, who is a senior program manager on the Azure Data Explorer team. And together we are going to deliver the session, Building Real-Time Big Data Analytics Solutions with Azure Data Explorer and Azure Stream Analytics. So the agenda for the next 60 minutes is something like this. We will talk about what is the need for real-time analytics. We are going to present the Azure powered pattern for real-time analytics. We are going to give a high-level description of one of uh, a very demanding customer from a workload and data throughput standpoint, which is Grab Taxi, and how Stream Analytics and Azure Data Explorer together helped solve some of their most pressing data analytics as well as business challenges. We are going to give you a quick overview of what is Azure Stream Analytics, some of the new features. Same thing with Azure Data Explorer. We will have a demo in between, and we will provide some of the resources that you could consult once you are done with this session. So if you have been kind of looking at the space of the data, how it has been growing and some of the forecasts around how much it is expected to grow to, right? The numbers are really compelling. It is expected that we will have 50 billion connected devices by the year 2030. Some estimates show that 175 zettabytes of data by the year 2025. And every IT department, large or small, will need to come up with a plan in order to harness and process this data in real time, not just to keep the storage costs in check, but also to deliver real time insights to stakeholders, whether it is on the IT side, whether it is on their business side. And culturally speaking as well, real time insights are in demand by customers, processes, employees. Like, let's start with customers first. When it comes to interactions with a business, it is no surprise that customers expectations have changed dramatically. All digital native customers, whether it is Gen X, Gen Y, Gen Z, all have come to expect so much more at every touch point, and everything is on the go, and every interaction counts, and every interaction is being expected to be near real time. Products and processes, right? Legacy products and processes are being re-engineered almost across every industry, and this involves fitting these processes with capabilities that generates more and more process and product telemetry. And there is a pressing need for these process and product owners to continuously measure, monitor, and improve on based on the data and the telemetry that is being collected. And finally, employees, right, who are really caught in this crossfire of expectations, and employees working in these organizations who are really starting to demand use of tools that can provide them the necessary capabilities to handle these telemetry streams in real time, and provide real-time customer service to all their stakeholders. So the real-time analytics use cases we are seeing across pretty much every industry, whether it is pricing optimization and IoT in retail or manufacturing industry, all the way to sensor data telemetry analytics and patient monitoring in healthcare, and so much more. Right. So we have customers from almost every industry, every vertical, using and benefiting from the use of real-time analytics capabilities that we have on Azure. So the Azure powered pattern for real-time analytics looks something like this, right? So you have the data sources that generate streaming data, whether it is machinery that is sending in machine telemetry, or if it is web server that is sending web log files, whether it is weather data, all of it is ingested through services like IoT Hub and Event Hub in Azure. And we really provide two leading capabilities to analyze real-time data in Azure, whether it is Stream Analytics for continuous real-time analytics or streaming analytics, or whether it is Azure Data Explorer, where you want to do on-demand or interactive real-time analytics, right? So you can also think of interactive analytics as exploratory analytics on data at rest. The biggest difference is that stream analytics analyzes the data continuously. It is analyzing data that is in motion, and Azure Data Explorer is more of a tool to quickly dig into and explore the interaction between the various different variables that might have caused an anomaly or something going right or wrong and things like that. And once the data is processed, either by Stream Analytics or Azure Data Explorer or jointly by both of them, right? Then this information can feed various activities like dashboarding, generating alerts, data warehousing, workloads in the downstream. So let's talk about how Azure Stream Analytics and Azure Data Explorer together can provide an immense level of joint value to you and your stakeholders, right? So like I mentioned, Azure Stream Analytics is all about analyzing streams of data in real time, and Azure Data Explorer is near real time interactive or exploratory analytics on data. There is, of course, a difference in the languages that are supported in both. Stream Analytics is primarily language that is a SQL variant, which is also extensible with C# and JavaScript UDFs, and Azure Data Explorer primarily uses KQL, but also extensible with Python, T-SQL, or R. But let's actually focus on what are some of the scenarios, joint scenarios, where Stream Analytics and Data Explorer really form a very good bond in order to come through on some of these real-time analytics scenarios. The first one is all about streaming analytics, continuously sniffing the data, continuously analyzing the streaming data, and the moment it finds an anomaly, sending that signal to Azure Data Explorer. And Azure Data Explorer is the place where analysts spend most of their time trying to understand why that particular anomaly came about, and maybe create certain patterns that could be of interest based on that anomaly, and go in and deploy that pattern in Azure Stream Analytics so that we can catch some of those anomalies even before certain anomaly actually take shape. The second one is all about deserialization of data. Stream Analytics provides custom deserialization capabilities. Let's say you have data coming in a protobuf format or any custom binary format. Stream Analytics can provide you ways to deserialize that data, and Azure Data Explorer downstream can actually use that deserialized data in order to aid with that interactive and exploratory analytics. Another scenario for Stream Analytics that we are seeing customers use in conjunction with Azure Data Explorer is, let's say you have a big fire hose of data that is coming at your way, and that data consists of data from n number of factories or n number of geographies, right? Azure Stream Analytics can fan out that data into smaller event hubs, smaller data brokers, and Azure Data Explorer can actually serve analysts responsible for that region or for that industry, and they are only looking at data that they are responsible for. And the next one is actually a data or storage saving scenario where Stream Analytics is aggregating the data in real time. Maybe there is not a need to look at 10 or 15 readings every second coming from a machinery. You are good enough if you're averaging or aggregating data across every 1 or 2 minutes, and then provide a much more reasonable amount of data that you store downstream that can be analyzed with Azure Data Explorer. So real-time aggregations filtering is also a scenario where Azure Stream Analytics filters or aggregates the data in real time, and Azure Data Explorer is actually working on a much more reasonable and reduced set of data. So as you can see, we have amassed thousands of customers in the last 3-4 years that we've been generally available in the market, and the list of customers who are actually using the service for mission critical scenarios just keeps growing. And every customer that you see here, there is a very nice customer case study documented that you can refer to on Azure case studies. So let me at this point give you a quick overview of customer success story, which is a joint customer story consisting of Stream Analytics and Azure Data Explorer of Grab Taxi. So what is Grab Taxi, right? Many of you might know who Grab is, many of you may not. Grab is a rideshare company similar to that of Uber. When Uber exited the business completely in 7 countries in Southeast Asia, uh, Indonesia, Malaysia, Singapore, Thailand, Cambodia, lots of countries, almost 7 countries in Asia, Grab actually bought the business of Uber. Grab was a smaller player, but they knew how to actually run a successful rideshare business. And like any rideshare company, they had some very pressing problems, right, which they had to solve in real time, right, because the rush hour lasts for just 1.5 hours every single day, and during that time they had to make a whole lot of their business happen. And if they were collecting telemetry, if they were making critical decisions with a lag, then they would have actually lost quite a bit of revenue and upside potential. So they had to know in real time what is the demand, where it is in different parts of the city, where is the supply, where are the drivers or the rides which did not or yet paired with a passenger located. They wanted to know in real time what is the price sensitivity or price elasticity in these different parts of the city, and also doing scenarios like fraud detection and merchant identification for real-time promotions and things like that. So they had many scenarios that they had to be very nimble and agile and solve in real time. So they worked very closely with us, and we did a joint hackathon with them. Now they are in production in every single country, and their architecture looks something like this, right? They have data coming in from the passengers, the riders, the merchants, and it is a big firehouse of data coming into this event hub here. And Stream Analytics actually fans out that data into various different smaller event hubs, right? That is very specific to a city or a geography. And those analysts who are responsible for a city, let's say Jakarta in Indonesia, right? They get to see all the data relevant to them that they need to analyze in a Azure Data Explorer session, right? And at the same time, they're also fanning out that data into Azure Stream Analytics for real-time alerts like scenario. Let's say the demand from a particular region in the city is higher than a particular threshold, then the analysts really need to know in real time that it is indeed the case, so that they can send some of the supply to the areas where there is much higher demand. And all of that data is being stored for further analysis in a SQL data warehouse for reporting purposes. And they use Power BI quite a bit, whether it is with feeding information through Azure Data Explorer or Stream Analytics for real-time dashboarding purposes, right? For the analyst to really get a sense of what is actually happened, looking at geo hashes or regions within the city with higher demand, lower supply, and so on. And they're also pushing a lot of data to Azure Databricks for downstream machine learning training and so on. At this point, let me make a little bit of a shift and talk about Azure Stream Analytics. So Azure Stream Analytics is a fully managed PaaS service on Azure for all real-time analytics requirements. It is based on Microsoft built open source now technology called Trill, which stands for trillions of events processed per day on a single core. And Microsoft is actually a leader in streaming analytics. This is a Forrester Wave for streaming analytics that was published in later part of 2019. And as you can see, Microsoft, among all the major cloud players, whether it is Google, AWS, Microsoft really is the leader, both in terms of the position, in terms of the market share, and we are actually seeing the demand grow really well over the last n number of months. So the point being, just be certain that Microsoft is going to help you with any real-time analytics requirements, right? No throughput is too high for us. No analytics requirements is too complex for us. If you have a real-time analytics needs, chances are we will most likely be able to satisfy that need. So what is it that really sets us apart from other solutions, right? The first and foremost, it is all about ease of use. We have a very simple SQL-like language that our users can use in order to express their analytics query. We've got zero code integration with over 15 different services on Azure. And the SQL language does support extensibility with JavaScript or C#. We are really ready for enterprise grade and mission critical scenarios, right? We provide 3 nines, financially guaranteed and backed up SLA on uptime. We provide guarantees around repeatability, no data loss, once only processing, etc. And we are a truly sort of hybrid solution where you can write the same query, deploy it in the cloud or deploy it on the IoT edge, or you can deploy it on Azure SQL Database Edge. In fact, all the streaming that actually happens on Azure SQL Database Edge is actually orchestrated through Azure Stream Analytics. And our differentiator there as compared to other competitors is that you can actually write the same query and deploy it in the cloud or on the edge. One of the key reasons why we are a leader in the streaming analytics space is really our innovation momentum. As you can see, we've been very busy releasing new features every quarter, every month on an ongoing basis. And what you see here are really features that are user facing, but an equal amount of investment, if not more, goes into improving the backend service to make it more scalable, to make it more secure, all of that. So what you see here are really the feature related investments. And one of the reasons why we are a leader in this space is because of this continuous focus and growth in the investments that Microsoft is making in the real-time analytics space. End-to-end architecture with stream analytics looks something like this, right? On the left-hand side, you have devices and applications that are constantly sending the streaming data into a IoT hub, event hub, or even blob storage. We have the ability, Stream Analytics has the ability to pull the data even from blob storage. In many cases, I hear customers saying that they are they are standardizing on Kafka as their data broker. So if that is the case, Event Hubs does support Kafka API so that you don't have to make any changes to your application and simply start writing to Event Hubs. Stream Analytics process these data streams, and while processing the data streams, you could also join multiple data streams, or you can join data streams coming from the left-hand side with slowly changing data or non-changing data, which is called data augmentation, reference data joins, all that is possible. And you could also do real-time scoring or real-time inferencing given our integration with Azure ML service, right? And once you do all of this, some of the key scenarios that we see customers doing with the streaming data is generating alerts and actions, dynamic dashboarding with Power BI. Data warehousing is a growing scenario and growing investment for us. And of course, some customers want to store all the data for cold path analytics or access and archival purposes down the stream, right? And also to train machine learning models and scenarios like that. So that, in essence, is an end-to-end architecture, how it looks with Azure Stream Analytics. Let me talk about some of the new features that we have released in the past few months. So let me first talk about Azure Stream Analytics Cluster, right? So very recently we launched this Azure Stream Analytics dedicated option, right? Primarily to help customers who need private endpoint support, right? So there is growing need for customers to ensure that these PaaS services are isolated and they are a part of their virtual network. So with the private endpoint support with Azure Stream Analytics Cluster, which is a dedicated offering, not a multi-tenant offering, we can actually support that requirement. And here, please note that the minimum size of the cluster starts at 36, and it can go to 216 streaming units. And this is also something where you can get commitment based discounts almost up to 45-50% for 3-year commitment to Stream Analytics. Um, like I was mentioning previously, investing into streaming with Azure Synapse Analytics is a big area of focus for us. And so previously, the adapter that we had that used SQL bulk loading capability peaked out around 10 to 12 megabytes per second. But with the new adapter that we recently put into general availability, you can achieve throughput rates almost up to 200 megabytes per second, a big improvement over where it was previously. And this adapter does provide some of these guarantees like repeatability guarantee, once only processing guarantee, and it does provide full administration and monitoring experience from Azure Stream Analytics that has really earned us big kudos from customers as well as the analyst community. The next feature, which again lots of customers are starting to use, is called pattern matching, right? So what we provide here is a very easy way for you to identify any anomalies or any patterns of interest with very simple functions, right? So let's say in this particular case, you want to identify those sensors. Let's say you have thousands of sensors, but the firmware update on some of the sensors has failed. And that firmware update is identified by a pattern of very high CPU utilization after the firmware update goes into effect, right? Let's say it goes in. Let's say it's identified through 3 very high CPU readings after the firmware update. So all you do here to define your patterns is first come here. Let's start from the bottom of the query. You are defining low utilization as utilization less than 30, and all these are parts of the telemetry or the attributes that are coming from the telemetry. You are defining low utilization as utilization that is less than 30, and high utilization as greater than 70. And whenever there is a firmware update that happens on a sensor, you are getting update as the value of the attribute, and on other times it is probably simply null or blank, right? So then you are actually defining your pattern. So you're defining your pattern to match as low utilization, so one incidence of low utilization, and then a firmware update, which is defined here, what an update means. And then you are looking for 3 instances of high utilization. So this is the pattern: low utilization, update happens, and then 3 high utilization continuously. And then whenever this happens, you want to send that sensor information to the analyst for further analysis, or show it on a dashboard, anything that is actually possible through Azure Stream Analytics. So we made this match recognize or pattern matching very easy for customers across various different industries, so that they don't have to go through what they had to go through previously in order to make SQL do this match recognize and pattern matching. Another major new feature that we announced recently is real-time scoring with pre-trained machine learning models, right? So here in this particular case, you can build the model right? Using any popular Python libraries as scikit-learn, PyTorch, TensorFlow, etc. You can train it anywhere as well, right? You can train it in Azure Databricks, Azure ML Compute, HD Insight, you name it. And finally, you host it in Azure Kubernetes Service or Azure Container Instances Cluster, and everything managed through Azure ML Service, of course. And once you have it deployed there, ASA can surface all the deployments available in Azure Machine Learning Workspace for you. You go to the functions blade in Stream Analytics, add Azure ML Service, and tie it to one of the deployments that you have on the Azure Machine Learning Workspace. And once you do that, we will do continuous scoring using that pre-trained, pre-built machine learning model that has been deployed using Azure ML Service, right? Finally, we do offer geospatial functions out of the box, right? You can define points, you can define polygons, you can create lines and strings, and using functions like distance, you can always keep track of distance between multiple points or multiple assets. You can generate a flag when a particular point lies within a polygon, right? Whenever the polygons intersect, you can raise a flag, and whenever the polygons overlap, you can do the same, right? So we have seen a lot of adoption of this feature from customers who are in the automotive OEM business, or customers who are in the vehicle telematics and driverless cars and fleet management like scenarios. So that said, let me now do a quick demo of our fleet management and maybe show some real-time machine learning in progress. So to do that, let me show this Power BI dashboard first, and then let's go into what it took to build this Power BI dashboard. Okay. So what I have here is data coming in from Manhattan taxis. This is a public data set. What we have done is to really replay that data in real time so that we can simulate some real time scenarios. So the first tile here actually shows what is the historical traffic versus the traffic pattern now combined across all the different regions of Manhattan. So as you can see, the historical traffic for this time of the day is much higher than the traffic pattern that we are seeing right now. The second tile here is we are seeing by region of Manhattan, Soho, Harlem, Chinatown, right? What is the aggregate number of pickups that are happening? Right. Looks like there is some problem with the data that is coming in because I'm only seeing data from Greenwich Village right now, but you get the point, right? We are aggregating the data across all these different regions in Manhattan defined by these geofences, and we are showing that on Power BI. This is where things get a little interesting. So what we are showing here is predicted fare in the next 1 hour in different regions of Manhattan. So armed with this information, right, the dispatchers can make the right call to send those taxi drivers that are waiting for new business in those areas to those regions where they expect to see higher fare at this time of the day or night. We are also doing something interesting here, calculating the average number of passengers in a trip across all the rides that are currently happening. And here we are seeing how many pickups are happening near the Microsoft Store, right? Microsoft Store in Times Square has fixed longitude and latitude information, and we are looking at all the drop-offs that are happening near the Microsoft Store. Near is qualified by within 100 or 200 feet. We will see the query and we will see that that are happening near Microsoft Store, so that the store manager can get some good insight on how much foot traffic they could expect to see within the store. Right. So that is the dashboard that we actually built. As you can see, it is very dynamic in nature. Stream Analytics enables dynamic dashboarding experience in Power BI. That is one project that we collaborated very closely with the Power BI team. Now let's look at what is it that is actually going on behind the scenes in order to generate that dashboard. So as you can see, we have inputs coming from the current stream data, which is the taxi ride information. right? And we also have reference data, right? For us to be able to aggregate information across different regions of Manhattan, you need to get that as a reference data, right? Those polygons that are created behind the scene. And then historical data as well to compare the real-time data with historical data. So we have a blob storage that is storing historical data. We have a blob storage that is showing these geographical polygons, and then we have stream data coming from Event Hub, which is showing the taxi ride information. We also have a machine learning function, like I mentioned, right? It is called a score. We are making a real-time REST API call to Azure ML service in order to do that fare prediction by region, what I mentioned. And then output is, of course, Power BI. But let me actually go through the query a little bit to show you what is happening in the query. So the first part of the query is where we are getting the longitude, latitude information from every pickup that is happening in Manhattan. And we are, kind of normalizing the data in a way that it can be picked up by the other parts of the query. Then what we are doing here is calculating the distance of the drop-off point to the Microsoft store in Times Square. So all we are doing is using the ST distance function to understand what is the distance between the Microsoft store, which is indicated through this longitude and latitude, right? And the pickup latitude and longitude information. And then we are just storing that information for now. And then we will pass it on to the next part of the query, where you're actually showing that as a drop off within 500 feet. Only if that drop off is within 500 feet of the Microsoft store, then you are going to increment that tile that shows how many drop-offs are happening near Microsoft Store in Manhattan. And you are grouping that by a hopping window. The window itself is 60 seconds long, but you're generating output every 5 seconds. This is the part of the query where we are doing machine learning logic. As you can see, we have that function called score that I had just shown you, and we are sending array of various different parameters that is required for that function that is deployed in Azure ML service to give you an output of what is the predicted fare in that particular region, right? So that ML function requires input in the form of an array, and that is the array that we are actually creating this using a UDF function, and we are passing on that information to the score function. And that's how we are getting an output of the predicted fare by region in Manhattan. So let's go back to the slide deck again. So this is the architecture for the job, right? And these are some of the resources if you want to know more about stream analytics, right? If you have any questions, send an email to this address. And for more documentation and pricing information, you can go to azure.com/SA being stream analytics, and at Azure Streaming is our Twitter handle. Thank you, everyone. At this point, I would like to hand over to Henning to take you through Azure Data Explorer.
Hello, this is Henning from Microsoft, and a warm welcome from my side. I'm a program manager for Azure Data Explorer, and I'm really happy to talk to you today about ADX. What is it? What are the cool new features that we recently released? What is coming next? And also I'm going to give you a quick demo of the data that has been analyzed already by Krishna using Azure Stream Analytics. So what is ADX? ADX is an interactive analytics service platform for fast-flowing data. It dramatically cuts down time to insight on data as it's flowing into the system in near real time. This actually means on a day-to-day job, for example, of a data engineer, the time that it takes from connecting the data with ADX until the data engineer can get some insights from the data is dramatically reduced. The second aspect is that it's fully managed. which means that it's actually a PaaS service on Azure. So you don't need to take care about things like auto-scaling. You get maintenance-free indexing and other really cool perks where you don't need to, where you actually can concentrate on your business logic rather than managing the service itself. And last but not least, our service enables a data-driven culture. We developed a very cool query language called Acoustic Query Language, which is proven to be very intuitive and easy to use. So you may ask, okay, you can tell me a lot, Henning, but is it actually being used somewhere? And yeah, definitely. So it has been developed or is in development since, meanwhile, I guess 6 to 7 years, and it's truly beta tested since I would say around about 2015, where it has been first introduced to technologies for logging and monitoring all telemetry data of Azure. And same goes for LinkedIn, Skype, Windows, SQL, actually all of the names that you see there. And this is usually a very big amount of data that we are talking about. Um, and once that it has been proven to be able to work with such a big data, such a big amount of data, people ask themselves, okay, what can we do with it? What else can we do with it? So a couple of SaaS offerings have been built on top of that. So software as a service offerings. First and foremost, I would say whenever you are somewhere on Azure and you create something like a web application, an Azure function, and you would like to monitor how it's behaving, you're usually using native tools based on Azure Monitor. Some of those tools are Application Insights, Block Analytics, and whenever you use those services, you're actually using Azure Data Explorer under the hood. Same goes for IoT products like Time Series Insights or IoT Central. Additionally, also all of the security products like threat detection, Azure Sentinel, and so on and so forth, Azure Security Center, just to name a few, are all based on top of Azure Data Explorer. So Azure Data Explorer is the true foundation of these products. All of them are storing their data in Azure Data Explorer and serve it to their customers. I almost forget about Playtime. Yeah, your gaming data is being stored there as well. And at some point, somewhere I would say late mid 2018, we decided to offer this beautiful platform to our external customers as well. This actually happened in beginning of 2019, February 2019. And ever since, we're working really close with our customers. And the pictures and the logos that you see here are just a few of them. Just to name some from BASF, the chemical industry, Bosch, which is the company with the most engineers in the world, Epi with EpiServer, Esri, DocuSign, Tabula, Ecolab, and a wide variety of others as well. So we recently, and we definitely saw since the beginning, really high demand in ADX, and you can really say that it's a battle-tested and proven technology. So meanwhile, we are using a significant part of the underlying infrastructure of Azure to run the service in terms of compute and in terms of storage. And it can really be considered a big data analytics service. Okay, if you're talking about big data analytics, and I'm based out of Germany and work with really big German enterprises, such like the automotive, retail, or manufacturing. It's very important that whatever you release, it needs to be enterprise ready. Otherwise, people in those big companies can't use it really. So one of the most important things here is authentication and authorization. We are following usually the RBAC model from Azure in general. And for authentication, we are using Azure Active Directory and nothing else. So essentially, you can define which Azure Active Directory identity, maybe a user or service principal or even security group, is allowed to access which resources in your database or on your cluster. Having said that, we also support virtual network perimeter security by implementing a virtual network injection. So you can inject Azure Data Explorer in your existing Azure virtual network infrastructure. We also support encryption at rest. Encryption at rest. This is like something that's been there at Microsoft since a very long time, mostly with Microsoft managed keys, but we also support functionality to inject customer managed keys. So you create the keys, you have them still in, let's say, in your offline bunker, and you have the control over the keys. So we support that. Encryption at transit, that's a given. And in order to increase the availability of our systems, we also support availability zones. So given in West Europe, you decide to deploy into West Europe, you are able to deploy into multiple availability zones so that your overall availability is being increased. Scale up and scale in is something that's supported based on various metrics. Recently also we enabled optimized autoscale, which is actually analyzing the way that you're using your cluster and sometimes even knows to scale out even before you do by analyzing the telemetry and the way that you are using your cluster. We are a globally available service because so many other services are built on top of Azure Data Explorer. Azure Data Explorer is one of the first services which is available in each and every region. We have a pretty good integration for CI/CD, maybe in Azure DevOps or other tools. We, of course, support automated provisioning, like the usual way through the Azure Resource Manager, so you can pretty much write everything that you do in infrastructure as code with Azure Data Explorer. And we also support monitoring inside out. So you may ask, what are actually the hero scenarios for Azure Data Explorer? In the beginning, I said that it's a platform and an analytics service for big data. But what we truly see in our customers, either within Microsoft or outside of Microsoft, that one of the biggest clusters of use cases is around telemetry and custom log analytics. Usually we see our competitors from Elastic or BigQuery or such kind of companies for those kind of big log analysis. And this can be either for some kind of internal use inside your company, but you can also build a multi-tenant solution. This is actually what most of our, let's say, Azure Monitor services did in the past. So you can deploy one instance of Azure Data Explorer, a so-called cluster, and you can host thousands of tenants on top of that. So Azure Data Explorer is a true multi-tenant service. The same goes for IoT and time series related analytics. The competitors in this space are some things like InfluxDB, for example, and all things where you need to build a custom IoT analytics platform. The same counts here for internal usage and also for external usage building SaaS platforms. This is something that's pretty much doable in a very, very easy and straightforward way. Azure Data Explorer, this is actually what you get when you deploy it on a very, very high level. Just start from the upper left side. So The first thing that you need to think of is actually how to get your data into Azure Data Explorer. We support native ways to ingest data from a storage or from an event hub, IoT hub, but we don't stop there. We also support open source technologies like Kafka. We have pretty good Kafka support. We have Logstash plugins. We also support Azure Data Factory. We have a native Spark connector. And when nothing helps, we always support you with APIs in any language. On the right-hand side, if you would like to query Azure Data Explorer, you can do this with the usual suspects like Power BI, Grafana. We have a really good Grafana support. We also support EXS through some orchestrators like Flow and Logic Apps. You can also use, of course, Spark to connect to ADX to create your data frames. We have a notebook experience, which enables you to connect, for example, from a Jupyter notebook or from a Databricks notebook to Azure Data Explorer. And recently, we also released a web user interface for dashboarding and for analyzing the data. Under the hood, if you take a look on the compute resources and where data is actually being stored, we are a scale-out database, a distributed system, and the compute resources under the hood are split into two parts. One part is the data management part, which is needed in order to manage ingestion queues, for example, and other things. And the engine part, this is the other scale-out compute part, is responsible for handling all of the distributed querying. Whenever you ingest some kind of data into ADX, it flows through those systems in compute and then eventually lands on an Azure storage. Some of the data, you can also call it cache data, is still being kept on the engine node local SSDs or RAM in order to speed up the querying dramatically. So some of the new capabilities that we recently released. Grafana now supports alerts. So the native connector from Grafana to ADX gets a lot more traction there. We recently also support Redash. And we created a Kibana proxy, which actually means that you can connect the Kibana dashboard through that Kibana proxy to an ADX instead of an Elasticsearch. We support reserved instances on multiple levels for blob, compute, and this actually means that that if you commit to Azure Data Explorer, that you can save a substantial amount of money. Bring your own key. This is what I already mentioned. This is one of our enterprise features, which allows you to create your own keys and use them for encrypting your underlying data. We did a lot of geospatial support. One thing that I'm going to show you in the next slide is also our in-place sharing using Azure Data Share. So instead of copying the data all the way around, you can just share your data. We support continuous export, which means all the data that is flowing into ADX can also be continuously exported. This is incredibly useful if you would like to implement something like a Kappa architecture. We have a full support for Parquet. On one hand side, when you want to ingest the data, when you would like to query the data, and also when you'd like to export the data. We support one-click ingestion. So with a couple of clicks, you are able to ingest, to create a schema, to create a mapping, and eventually ingest a big batch of data. Last but not least, we also have now in preview our operational dashboarding capability, which enables you without deploying any new infrastructure to have a true dashboarding experience on top of ADX. Some quick words about data sharing. So you are able to actually link to Azure Data Explorer clusters in a symbolic way. and then use the data from a so-called leader cluster in your follower cluster. So what does it help? So it actually helps you to share data within the company. It also helps you load balancing, and it actually enables you to serve as a data as a service provider. And it doesn't stop there. You can also share data with other partners outside of your company, even outside of your Microsoft tenant. So this is pretty nice to set up. This is what I wanted to say. Yeah, you can share data with your customers and create a new business model from this. The main key points to remember here, it's an in-place data sharing, so it's actually no copying of the data. You don't need to maintain any pipeline to get new data. This is all automatically handled under the hood, and you get near real-time updates of the data. Geospatial support has been added, I would say, now half a year ago, and we continue to extend our support. It starts from very simple methods of calculating distance between 2 points, between a line, but we also support various grid systems for calculating S2 cells, geohashes, work with polygons and circles, and so on and so forth. Already talked about this. This is our Kibana proxy, very useful if you have a lot of Kibana dashboards and you would like to use them on Azure Data Explorer. Our dashboards that come out of the box are pretty neat, and you're able to create nice dashboards on top of your data in a very easy way. The roadmap is it's actually quite simple. So we're working since quite some time on lifting our engine from the version 2 to version 3. This will provide you a dramatic performance boost. We also recently implemented partitioning and continuously improving that, which will help you in a lot of IoT scenarios and time series analytics scenarios. Materialized views is a way to calculate certain KPIs and then materialize them so that you don't need to recalculate them over and over again. Please find some resources here so you can look it up yourself and calculate the cost. Take a look at the docs, and also I can only encourage you to take a look at our Pluralsight course as well. If you have some kind of feedback, some kind of features that you would like to have in our product, feel free to go to feedback.azure.com to this link, and then we'll take a look at this, evaluate this, and eventually build it. Now, first of all, thank you for your time. I would just like to go through some highlights of my demo of the data that Krishna prepared up front. So let me switch to a tool which is called Azure Data Explorer. It's actually this one. And so now the data that Krishna produced, it needs to land somewhere. And in this case, it lands in Azure Data Explorer. So we take a look at it, see how much it is, and we find out that it's close to 105 billion rows. And now we would like to do some kind of analytics on top of that. So this is actually equals to query language. You see the output of line number 12 is the input of line number 13, and then it builds on top of that. So we make a simple where statement, then we do some time series analytics, and then we render it. This is just the number of writes per week. And remember, this is running on 1.5 billion rows. So you see the number of writes of those New York City taxis goes down, down, and down. We can calculate now some simple statistics, like standard deviation and variance. We can just calculate something like the moving average over the count of writes over time. You see here the blue line, this is the moving average, and those are all live queries. So this is nothing cached, and it always runs on 1.5 billion records. And this is a pretty interesting thing, because you can do some kind of regression analysis to find out at which point the things change, and must have been sometime here, and you might guess what it is. Series decompose is very interesting because you see what are the things that we are analyzing under the hood in order to do some things like anomaly detection or forecasting. So we divide a time series into seasonality, trend, residual, baseline, and all of those kinds of things are split up here. And this is just to show you what we're using to do this. Anomaly detection is equally simple. So you create a time series and then run anomaly detection on top of that. You see here there were 2 spikes, and here's a spike as well. And here are some anomalies as well. At the moment, I don't know the reason for that, but what we can also do is we can do an interpolation of those anomalies and see whenever there's an anomaly, we just do a linear interpolation and look at this. See, the blue line was the original one, and the red one is now the interpolated version of it. Forecasting is the same, as simple as this. So we just need to use a different function. You see here, the red one is the number of trips, the count of trips, and the blue one is the actual forecast for it. This works the same way for multiple time series where we were incredibly strong. So here, multiple time series. And remember, running on 1.5 billion rows in 1 second. And this is on the West Coast, so on the other side of the planet for me. Thank you very much for your time. It was a true pleasure, and I hope that this talk helped you getting some news about Azure Data Explorer or finding out what it is. Don't hesitate to contact me or contact some of my peers on any channel that you like. Thanks a lot, and have a great rest of the day. Thanks.